All right, I had to wait for the trash man to go by in his loud truck, but hopefully you got everything with the thermostats. Capacitors, okay? We have to talk about motors now. We just got no time to put it off, and it's something that I try to save toward the end of the semester, but so that way you remember it, because you're gonna forget. I forgot. You're gonna forget. Um, it just happens. I'm purposely doing it now. But capacitors, we've talked about them before. We all know that they are, let me zoom in there, right? Capacitors are rated in microfarads. There's one right there, okay? I'll just hold it up. You can see this one is a 10 microfarad capacitor, okay? And there's a tolerance, a plus or minus value. So plus or minus 3% of 10, the capacitor at its stated value can be 3% higher in this case or 3% lower. Do a little bit of math and um, you'll get those exact numbers, and that establishes a range. All right. And if it's out of that range, then by the manufacturer's details, by their specs, then it's a bad capacitor. Oh, excuse me. I drank some tea and ate a cookie for breakfast, so I'm being healthy. But you have to watch that value. Capacitors are definitely important um, for our PSC motors. We have a lot of PSC motors. Okay, part of your assignment for this week is in the heat pump class is going to be to read chapter 17 and kind of preview everything on the motors. I'm going to do a couple of videos on two specific types of motors. But the PSC motors, we've talked about those before. We've drawn the run windings and the start windings on the board, talked about how it works. But we're going to do a little more focused video on that later. But capacitors are definitely important for a PSC motor. Without it, the motor will not start. All right, the capacitor is going to be wired into the start winding. Every capacitor, this particular one is a run capacitor. It's the silver metal housed one. There's a start capacitor. That's the black plastic one, if you remember. They're both rated in microfarads. They both use the UF or the MFD, or you might see the actual symbol, electrical symbol for it on a wiring diagram. But they're all rated in capacitance, microfarads. Okay. PSC motors are not the only ones that use a capacitor to start. But for our purposes, that's the one we're going to talk about. They are also, besides a capacitance value, you'll see that they are rated for a voltage. This particular one is a 440 volt rated capacitor. There is also a 370 version out there. And what this is the voltage that basically the voltage that this thing is rated for. We typically, use these on our 240 volt heat pumps or 208 if we're at the shop. But you don't want to apply more voltage than that, than whatever it's rated for. You don't want to put any more than that on there. And the capacitor will typically, when you put 240 volts into it, or 120 volts into it, or whatever you have, it's going to increase the voltage a little bit, but it shouldn't be over that. Okay, so if you ever had to replace a capacitor, and I'll just use this 10 microfarad as an example. What if this was a 10 microfarad at 370 volts? And I didn't have one of those exactly, but I had this one in my hand. I had a 10 microfarad at 440 volts. Can I replace the 10 microfarad at 370 with a 10 microfarad at 440? Absolutely. We've talked about it before. You can replace a 370 rated capacitor with a 440 volt rated, but you cannot replace a 440 volt rated with a 370 volt rated. Okay, it would always be best. Put a little note right here. If you have a choice, buy the 440 volt rated ones. You can use them in place of 370 volt rated capacitors and 440 volt rated capacitors, and there's no issue with them. Just make sure that you have the right microfarad rating, the right capacitance for it. So, how do you check these? You can check them with the power off, or you can check them with the power on. If I check it with the power off, then y'all remember my little saying, right? Power off, the wire's off. So you have to unwire it just like that. Okay. Go get your meter. We're going to turn my meter on. It's my favorite meter. I've had it probably 15 years. And you can see that my meter displays the UF. So I'm going to put that there, put my meter down. And with the wires disconnected, off of it, I simply attach or touch my leads to it. This is a 9.95 capacitance capacitor, or it has 9.95 microfarads. Is that good? We'd have to do the math. So let me do the math real quick. Had a garbage truck again, so I paused it. But anyway, we did the math, right? Longhand. If I take 10, which is the rating, and I multiply it by 3%, which is 0.03, all right, if you do it longhand. You do the math, right? You have two decimal spots, so the zero, you bring a decimal over, and I get a range of plus or minus 0.3. So if I go from 10 and I go down 0.3, then I have to be at 9.7. 9.7 microfarads is the low end of the scale. If I add the 0.3, then 10.3 is the high end. As long as I'm in that range with my value, then I'm good. If I go outside of that range, then this capacitor needs to be replaced according to the manufacturer's instructions, okay, or their details and specifications. So we had a 9.95. We're pretty much dead center. This capacitor is good, okay. That's one way to check it. That's with the power off, okay? Then, of course, you put that back in, wire it back in, no problem. There is a formula that we can use to check it with the capacitor being used, with the motor running with power on. And basically, this is the formula here. 2650, which is a constant, times the amp draw. What amp draw am I talking about? One second, I didn't forget. If you've got this thing wired in, then you're going to basically take an amp reading on the wire that goes into your motor. Okay, that's the amp draw we're looking at. Voltage, you're going to take your voltage across these terminals. You're not when the power's on, you leave the wires on, right? So you're going to take a voltage across this, and it may be 250 volts, it may be 300 volts, depending on if you're checking a capacitor for a compressor or a small fan motor. It just depends. But this is what you would do, right? Voltage across the two terminals, and the amp draw going out to your fan or your Herm, your compressor. So, and you can fill in those numbers. I'm not going to do this live again. We've done it before in the shop, but just so you remember. And that's pretty much capacitors for right now.